Hello, Nico. How are you doing?
Hi, sir. I'm under the weather, but I'm good for the most part.
Oh no, what are you taking for it though?
I just took a Advil cold and sinus, but that does seem like it'll help. Like me need something
Yeah,
stronger.
man. You are so nasal though. Very, very nasal.
Listen,
Oh,
and
Jesus.
then it comes with a headache that no seem as
Evening.
if it's gonna go away.
Hey,
Hi,
JJ.
hi,
Oh,
Juliana.
yeah. I know. Take time call that word for me here because there are many nights I come into this class with a terrible headache, and it's me and them headaches. They don't work at all.
Yeah,
I hate those headaches. Jeez. Are you drinking enough fluids?
yeah, man.
Yeah,
Well,
man.
just started to get hydrated, so
Yeah, just get some fluids and stay away from the cold fluids. Get us much
yeah.
room temperature, or if you can even get some hot fluids because you don't want to tighten the mucus on your chest.
Listen.
Are you getting time off from work because you're going to need some rest, in order to recover too.
No, I opted to work from home, but I was saying to myself that I just probably just gonna take some sick days because the
Yeah.
headache not allow me to function as how I'd want to.
All right. I understand. Just say as best as you can listening. I won't trouble you so much. Tonight's supposed to be a little fun. I want to just maybe give a few questions on the integration that we've been working on, and then I want to move into some applications. We have already completed the applications of differentiation, which is the stationary points.
Yeah.
I just want to look at some applications of integration now, and then so it should be light. You know how to integrate already, so it should be light.
All right, sir, no
All right,
problem.
all right, pick up yourself. Hey JJ, what's up?
Sir?
You good? Getting better? I should ask.
Yeah, trying,
Yeah,
sir,
man.
trying.
Um, I don't want it.
Yeah, sir.
I don't want it. I don't want it to interfere with what is happening for this semester here.
No, no, it won't, sir.
Right. We're on a mission, and we're gonna
Yeah.
we're gonna we're gonna complete we're gonna complete and finish the mission. All right.
Yes,
So I
sir.
soon I soon
All
put
right.
some I soon put some well, I'm in the process of putting some do no questions on the thing, so you can just warm up until it's time for me to begin. So give me about five, and I get some questions up for you. All right, sorry, students. I am having a senior moment. Though I know I'm almost sure it was done, I just want to confirm. Did I do multivariable functions with you um, in finding dy by dx and like an explicit differentiation?
I'm not sure if I do. think I think you probably told me something like that.
Did I give you something like that, guys, to work on? Somebody answer, please.
Yes, sir.
And then I'm a phone like dy by dx, and we're able to get the differential, and then we substitute the values in it. Yeah? No? Maybe so? I heard just one person say yes. What about the others?
Yeah. You hear me, sir?
Yeah, I hear you, Crosswell. Okay, all right. Are we finished with this
Yeah, I
question?
see the screen here. Yes, sir. What word?
You're not seeing the whiteboard, Crosswell? All right. Only if you talk to me. I'm asking the question and nobody's responding. All right, you know what? Let me give you some time. When you
Sir?
finish, let me know, please.
Sir?
Somebody say, yeah,
Sir, I'm just informing I'm on the road.
fair enough. Fair enough. When you guys finish with the questions, let me know so I can come back.
Yes, sir.
Good evening, everyone.
Good evening.
Are we finished, students?
Hi, sir. No,
All right.
I just
Mm,
joined.
all right. I'll give you a few minutes. I'll give you 10 minutes, guys. We need to go though. 10 minutes more, please.
Yes, sir. I got now too.
Mm.
sir.
Hello?
Mr. Shand.
Hello?
Hi, sir.
Hello, my
So,
daughter.
I'm looking at the question, particularly the first one. I don't know if it's because I'm tired, but I'm seeing three different ways that I could possibly work it, or I don't know which will be correct, but three different ways to work it to get to an answer, and then I find out which one is correct, which method is correct. So
Mm-hmm.
basically, sir, I'm at a standstill. I don't know what to do with this one.
All right, move to the second
Yeah.
one then. Move to the second one. And
Yes,
then
I have. Mhm.
all right, and then I will go through the first one with you. All right, that's my timer. So I'm gonna pause you and pausing you so that I can go through question one. So there are two things at the start of the integration differentiation. I did say to you when there's going to come a point where you have to integrate and then you have to differentiate and then put it back and showing you how one works with the other. So I'm going to show you the grown-up way of doing this question. Maya Bo, I want you to.
Yes, sir, I'm looking.
All right, good job. And the rest of you, please just put the pens and pencils down and just look at what I'm doing. So I'm going to be treating 2x minus 3 to the third power as if it were x raised to the third power. Yeah. If this is x raised to the third power, how do we integrate x raised to the third power?
So it's going to be all of that which is in the bracket raised to 4 over 4.
Very good. And then the trick to this now, you're going to be multiplying it by the reciprocal of the differential. You're going to be multiplying it by the reciprocal
Yeah.
of the differential. What is the differential
I
again?
knew it was something. So the differential it will be 2,
So therefore you're going to multiply it by
2/1
the reciprocal of 2
or
is
1/2.
1 over 2.
Mhm.
You're multiplying it by the reciprocal of the differential. So so now I'm going to have 2x minus 3 to the 4th power over 8. All right. And 1, 0. So this is going to be 2 times 1 minus 3 to the 4th over 8 minus, where's danger? 2 times 0 minus 3 raised to the 4th power over 8. 2 times 1 is 2. 2 minus 3 is negative 1. So this is negative 1 raised to the 4th power over 8 minus 2 times 0 is 0. And this is going to just be a negative 3 raised to the 4th power over 8. And negative 1 raised to the 4th power is simply negative 1. Nope, it's positive 1, sir. So it's going to be 1/8. And negative 3 raised to the 4th power is going to be 8 to 1. Positive 8 to 1. So this is going to be minus 8 to 1 over 8. Denominators are the same. So I'm going to just have 1 minus 8 to 1 over 8, which is the same thing as negative 80 over 8. That is equal to negative unit squared. That's your answer.
Great, sir. Awesome. Great job.
So it's
So
not. Go ahead, my
I
love.
missed I missed the reciprocation part.
Right, right,
So yeah,
right, right.
I did not do that.
No problem. But no, you know. But
Mhm.
I'm gonna do it the way that I expected. This is a grown-up way to do it, and this is a way that I want you to do it. But I'm gonna do it the way that I hold on. Should I? No, I'm not gonna do it because I don't want to give anybody any ideas.
Give
No,
me ideas.
yeah, no ideas. No, let us do it the grown-up way. We're gonna stick to this way. We're gonna stick to this way. But no, let me show you this one time how we can check our answer. Well, not check. I'm just going to show you something. It's not a matter of checking our answer. I'm just going to show you something. I don't want any of you to do this. I'm just the grown-up way of doing the question is how I just did it. The grown-up way of how I do the question is how I just did it. But then again, oh Jesus, it you may not even know how to do binomial expansion. Hold on. Should I? Should I not? I am going to do it. If you don't understand it, I'm not going to explain it. You just leave it alone and do the grown-up way. 2x minus 3. 2x minus 3. You know what? Let me just do it over here, and then I can do the question down there. If you don't understand what I'm doing here, it's just fine. I just want to show you that it can, it can work another way. The integral of 1, 0, 2x minus 3 raised to the third power dx. So I'm going to expand binomially. So my coefficients will be 1, 3, 3, 1. I think you'd have done this in discrete math. So this is going to be 2, 1 times 2x, 1 times 2x raised to the third power, plus 3 times 2x raised to the second power times negative 3 raised to the first power, plus 3 times 2x raised to the first power times negative 3 raised to the second power, plus 1 times negative 3 raised to the third power. So 2 2 is 4, 4 2 is 8, so this is going to become 8x cubed, plus 4 3 is 12x. Woo! No, no, no. Let me just fix up this a little bit. Negative 3 times 3 is going to be negative 9. So it's going to be a negative 9 times 4. 4 9 is 36, so it's going to be minus 36 x squared. Check my session, don't want to make any mistake. Negative 3 times 3 is 9. And 9 times 2 2 is 4. 4 9 is 36 x squared. Okay, good. Negative 3 squares is 9. 9 times 3 is 27. And 27 times 2 is 54. So this is positive 54x. And negative 3 times 3 is negative 27. So that is what that works out to be, dx, and now I have the integral of that. So that's what that is. So I use a binomial expansion. All right. Come on, pen. Binomial expansion. All right. So to evaluate that thing pretty quickly. So this now is going to become 8x to the fourth over 4 minus 36 x to the third over 3 plus 54x squared over 2 minus 27x 10. So this is going to be, ooh, this is nice. Let me just show you something here. 4 into itself 1, 4 into this goes 2 times, 3 into itself 1, this one goes 12 times, this and that one goes 27 times. So what I now have is x to the fourth minus 12x cubed plus 27x squared minus 27x 10. So this is going to be, no, 1 to the fourth minus 12 times 1 cube plus 27 times 1 square minus 27 times 1. And this is just minus 0. Do you agree that it's just minus 0? So this is going to be 1 minus 12 plus something don't look right. Something looks that. So 1 minus 12 plus 27 minus 27. And in that case, that goes to 0. And I'm ending up with 1 minus that, I'm ending up with negative 11 units squared. All right, hold on now. So let's just double check. Let's just go back to the calculation, because here I got minus 10 units squared. Now I'm getting minus 11 units squared. All right, hold on. Let me go back to my binomial. Oopsie. Let me go back to my binomial expansion. 1331. 1 times 2x to the third, that's correct. Plus 3 times 2x squared times negative 3 to the first, that's correct. Plus 3 times 2x to the first times negative 3 squared, correct. Plus 1 times, that will be 2x to the 0, which is 1, minus 3 to the third power. 3 3 is 9, 9 3 is 27, minus 27. Negative 3 squares is positive 9. 9 twos are 18. What is 18 times 3? 18 times 3 is? 54. Good. So that is correct. Negative 3 times negative 3 times 3 is negative 9. Negative 9 times 4, 4 9 36, negative 36 squared. And this is going to be 2, 2 twos, 4, 4 twos, 8, 8x cubed. All right, so that's correct. I'm adding 1 to the power divided by the new power. Boom, bam. 8x to the 4th over 4. 4 into 8, 4 twos, 8, 2x to the 4th. Oh, crap. So my error is here. Um, you notice I put the, I put back this 12. You notice this 12 is right here, and this 27 is right here. Anybody see that?
Oh, yeah.
Where is this 2?
You ate it.
I ate it, right? And because I'm hungry now. So that's supposed to be 2 there, and that's going to be times 2. Mm. All right. Now, let me just point out something to you. Did anybody hear when I was in the question I said something don't look right?
Oh, yeah.
All right. So when you're working the question, well, I don't know if you are there just yet, but when I'm working the question, what I'm writing, I'm actually one step ahead in my headspace, so I know what is coming next. And
Mm-hmm.
when I was writing, I said to myself, "Oh, but I'm writing, but I'm evaluating the steps ahead of me, and I recognize that this is not coming out to negative 10." So I knew that something was a little off,
Oh.
right? So that's why I said what I said. All right. Mute from mute from
Yeah.
him, Mario. Right. So what is happening here is it's I did it. I didn't want to do it, but then again, I thought to myself, let me do it. All I'm doing there is expanding my 2x minus 3 raised to the third power. And let me tell you what I'm fearful of. I submitted the block scheduling grades today, and for the most part, they're excited. I'm excited for them too. Um, it's just one student I didn't get through, and I'm annoyed because when teacher teach, listen to what teacher says. When teacher teaches, listen to what teacher says. And even though I'm going to say this now, I know some of you are going to do something other than what I'm instructing. If the question comes like this, you can do it how I did it in blue. But oftentimes they put the question like 2x minus 3 to the 7th power, or to the 6th power, or even to the 5th power. No waste no time, but you're expanding something. Because when you're expanding, you are going to make errors like I did. I left off the 2 and got negative 11. And I would have lost 5, 6, 7 marks. As opposed to one applying the principle in this step. Much shorter, less calculation. Can you say that it's less work?
It is. It definitely is. And yeah.
So what you're doing when you get like the power rule, it looks like the power rule to integrate, you're going to integrate as per usual. 2x minus 3 raised to the 4th power divided by 4. But what you're going to be doing now is to differentiate what is inside the parentheses and then times it by the reciprocal. So you're going to multiply it by the reciprocal of the differential. So you're going to differentiate what is in the parentheses.
Answer. Sorry.
Hmm.
So first, so this is I identified when I was doing it that this is the power. So I figured that we'd have to do some kind of differentiation of what is inside the bracket, but I
Very good.
wasn't sure of
Very
how
good.
the next step. But then, yes, you say we differentiate what is inside the bracket and multiply it by its reciprocal. That's what
Very
you
good.
said.
Very good.
So if we did not
Reciprocate it?
no, hold on.
Okay.
So the reciprocal of anything would always be
1 over that thing.
but you
But
say
what the
multiply by
right,
its
but
reciprocal.
the point I want you to tell me now, because I was trying to preempt you, but you're not there yet, so I'm going to come back to that.
Mm,
Remember, for the differential, what we did, we differentiated the inside and multiplied by the differential.
mhm.
True or false?
True.
Yeah, man. So you can't be the same thing as multiplied by the differential of what is inside the parentheses. No, this is integration, which is the opposite of it. So you have to multiply by the inverse
Mhm.
of it, which is going to be 1 over.
Okay.
All right.
Yes,
So
sir.
that wasn't bad. Go
I'm
ahead.
still not there yet. I'm still not
And
there.
that's fine. And
I'm
that's fine.
trying to
And
I'm
that's fine.
trying to do something. So the difference, starting step by step, the differential of what's inside the bracket is 2, right?
Mm-hmm.
I say
Correct.
we multiply the differential by its reciprocal, which
Good
is
job.
a half. But that when we multiply that, we still get a half, I guess.
Mm-hmm.
Oh, so that's why we have a half.
No, when you multiply by the
No,
reciprocal, when you multiply by the reciprocal,
yes,
no, man. You're correct, but you said something that I want to just
that's,
clear up.
let me
So
say, yeah, a
you're
half.
multiply,
Mhm.
right? Yeah.
Yeah,
So you're multiplying by a half. How did we
right.
get? Okay, all right, okay.
That's what I'm saying. That's why we get a half because the reciprocal of
2.
wait, the reciprocal of 2 is a half, right?
Okay, yeah, correct.
Yeah, and half of 2 or 2 multiplied by a half is
4,
still a half of 2. So that's why we have a half there.
and that's what he said wrong. That's why I was coming in.
I
No,
know, sir. I know. I know it's not the correct thing. I was just thinking why you get a half there because I know the reciprocal of 2 is a
okay,
half. So that's
okay,
what I'm saying why I thought it was just the 2. I didn't know that you have to multiply the reciprocal by the
okay. Got you,
differential.
got you,
Yes, so
got you,
that's
got you, got you, got you. Boy, the rest of the money from last
so
week, you're
in
noticing.
other case, sir, if it was a 3, it would be 3 multiplied by 1 over 3, which will give a 3 times 1, 3, which will be 1. Yeah, that's what I get.
They what now?
Sir, yeah, it's you're foolish, certainly.
But if it is multiplied,
Sir,
if it
if
is
the differential, if this was 3x minus 3, the value or the differential of that would be 3. And you say
good,
we multiply that by the reciprocal of what is differentiated, which will be multiplied by 1 over 3,
full stop.
right?
Yeah, full stop. Don't say nothing more. That is it.
Mm-hmm.
That is it. Not more. Nobody can tell me not about no half again. Yeah,
No, I'm not saying a half. I'm just telling you when you multiply 3 times 1 over 3, it will give you 1. And
okay.
that me
All right.
not
Okay.
understand,
No.
sir.
You're correct. You're correct. It's just that you said it in the same sentence or in the same
Mm.
breath. So I was wondering where it is that you're coming from. But if you paused and put a comma there and to say you're multiplying by 1 over 3 because 3 times 1 over 3 is 1, I can understand. And you're perfectly correct right there.
Okay.
Hmm.
Okay,
All
great.
righty. So I'm not going to do. I was going to move into something else, but I think I may stay here a little bit longer. I'm going to tell you why. I want to give you 2 more rules. I want to give you 2 more rules of the integration. I want to show you how to integrate an exponential function, and I also want to show you how to integrate a logarithmic function. But before I do that, though, Yeah, man, trust me. Hey, Matt's nice, you know, man. Relax yourself, man. So what it is that we're going to do is I'm going to give you 5 minutes to finish off this question. This question is much easier than the first one. 5 minutes to finish off this question, please. Starting now. All right. Sorry about that. I stepped away. So if you were calling me, I wouldn't have heard. Let us go to this one, please. Quick and fast. Um, I want us to be reminded of the method that we're adding 1 to the power. So this is going to be 4x cubed and divided by the new power 3 minus 2x squared over 2 minus x, and this is going to be 2, 1. If I were to simplify, that 2 cancels that 2, so I'm left with 4 over 3 x cubed minus x squared minus x, 2, 1. And now I'm going to go ahead with the substitution. 4 thirds 2 cubed minus 2 squares minus 2 minus 4 thirds to the first power, 1 cube minus 1 square. Okay, I see that. Hold on a minute, please. All right. I want you to help with the calculation here. 2 cubes are 8 minus 4 minus 2. That's 4 cubes. That's 1 cube. Minus 1 minus 2. 4 8's 32 over 3 minus 6 minus 4/3 minus 3. And I can put that safely over 1 and this over 1. And then I can say the LCM here is 3. 3 into 3 goes 1 time. 1 times 32 is 32. 1 into 3 goes 3 times, and 3 times 6 is 18. Similarly, LCM here is 3. 3 into 3 goes 1 times 4 is 4. 1 into 3 goes 3 times, and 3 times into 3 is negative 9. And then, oh, I'm going to say 32 minus 18 is going to be 14. Work with me, you know. It's the end of the day. And 4 minus 9, or this is negative. 4 minus 9 is negative 5. So it's going to be a negative 5 over 3, which works out to be 14 over 3 plus 5 over 3. And I'm getting 19 over. Anybody got 19 over 3?
Sir, where you have the 4 over 3, 1 cube minus 1 square, you have negative 2. Shouldn't that be negative 1
So you
minus
wait
1?
until me reach so far, then you ask me.
That's
Sure.
me, I wonder.
Sure. Wait until me reach so far. Where are you talking about? Right here, so?
Yes, sir.
What you asking?
Where have
Third,
the
yeah.
4
Yeah,
over
yeah, it's
3,
for
1 cube minus 1 square minus, it should be 1, not 2.
Because the X is 1
Oh,
over
right here,
on that
so?
side, yeah.
Yes.
Sir,
Oh,
that's time I wonder why you get
yeah,
19 over 3.
just you wait until me reach so.
Well,
Sure.
me just start to pay attention to you're
Sure.
working on
All right, so this supposed to be 1,
16 over. Oh, yeah.
and that's supposed to be 1,
Ah,
and that's supposed and then this supposed to be 2,
right.
and then that's supposed to be 6, and then 4 minus 6 is minus 2, and then 14 plus 2. Is it 16 over 3?
Sir, yes, still. Mm. Oh, yeah.
Is it 16 over 3?
Yeah.
Yes, sir, that's what I thought.
Come on, thanks though. Next time, don't wait until me reach so far. Sure.
So you wear glasses? Oh, yeah,
Long time.
you do wear glasses. So
Yeah, but
can't see picture again.
All right. So guess what? Very good. I'm happy that you're able to follow what it is that I'm doing, and these are things that can happen in the exam. But you see, the truth is, when I am marking, and if I saw the error right here, so you'll be penalized at that point. But if you use that incorrect answer right here, so correctly in the other steps, I would give you partial points right here. Fair enough?
Yes, sir.
So I have a question.
Go ahead, Papa.
All right, so for the first question, right?
Mm-hmm.
Do we only use that method when the power outside is above like 2?
Yeah.
Only when it's above like 2 and above.
Okay. You use that method when the power is not 1 and not -1, but every other number. So it could also be a negative number. So I hesitated because I wanted to answer you appropriately.
All right.
And because you asked a question, the way you asked a question, I think you guys get this now. Because you asked a question, the way you asked a question, I think you're thinking, uh, yeah, yeah,
No, the reason I asked that question is because um, if there wasn't like a set power you're supposed to use it with, so for example, right, the first one is 2x minus 3 cubed, right?
mm-hmm.
So we can use it right there. But for the second question, it's only raised to the first power.
That's
So
right.
there would have to be a limit to the, or a
Mm-hmm.
minimum, sorry, to the
Mm-hmm.
power it's supposed to raise to. Because you could have just used it on the second one if there wasn't then. So that we want to clarify.
Mm-hmm. But the point I want you to recognize though is that had it been a -2, I could still use it with a -2.
Yeah, yeah.
Okay, got you. All right. How we feel now? Are we feeling okay, or you want one more for the road? Talk fast.
One more.
Man, next one.
All right. I like your energies. Always well appreciated. Um, yes, Adrian, you can. All right, on the mark, get set, go. I give you 7 minutes for this one. All right, guys. So we say, are we finished? Hello, are we finished?
No, sir.
No.
Okay
Sir,
then.
I want to go on from a laptop.
So I get a
Okay.
piece of the answer then.
You get a piece of an answer?
No, I get the answer, but
All right. Go on, hold on to it. Hold on for it another 2 minutes or so.
alright.
Want to see what it look like. Come, guys, hurry up. Hurry up, hurry up. Another 2 minutes. All right, finished now? Okay.
Sorry, I'm a bit lost.
Okay, somebody tell me an answer, please. I need to hear an answer now. Any answer.
So we get
Sir,
two different answers depending on how many links or how I put my calculator. We get 63 units squared, and the next one is negative 58.5 units squared.
Okay, all right, noted. I saw that answer. Okay, I'm seeing those answers. Any other answer?
sir, I am. I'm still evaluating mine because I had to start over. So, uh, turns out I was not understanding exactly what I was saying earlier. So, but I think I have it now. I think, I hope, I hope.
What do you have?
A syntax error.
Well, that means you done got it. All right, let's go. Let us go.
Sir,
All right.
sir.
Yes, yes, dear JJ. Sorry, you were saying that you're a bit lost. Tell me now.
Yes, sir, because of the power. Because everything is to the second power is like, how do I, what's the word? It's not differentiate, but, sir, you know what I mean?
No, you tell me.
I can't remember the word. Is it integration, sir?
Yeah, yeah, that's what we're doing. We're integrating.
Right. So I think because of the power is like I almost got confused and now I think I confused myself, so I don't know what to do now.
Okay. All right. Mm. All right, let's go. Let me back before I do that. I want to heard about 3 or 4 answers. Anybody else? Students, if we don't talk up and participate, and not going to do the question, because some of you may be sitting down here and think, say, oh, I don't have to work because they're going to work the question anyhow. I will work the question and give it and send it off to those students who give me an answer. So I need to hear from the rest of you. Come on. Yeah, brother, just ease off the noise now. Yeah.
Sir, I got 90. Oh, nice. I got 95.4.
95.4.
Mm.
Anybody else? Mm. Yeah, man, just continue working, man. You should be fine. Anybody else? Okay. So I'm adding 1 to the power. Dividing by the new power. What's the differential?
4x cubed.
Multiplied by the reciprocal of the denominator. I mean, of the differential, sorry. So we're going to have X to the 4. The integration is finished right there. X to the 4 plus 2 all cube over 12x cube. Is that correct?
Yes, sir.
Right. So the integration is finished right there. There's nothing more to the integration than that. What is now left to be done is algebra. And algebra is little school mathematics. Literally little school mathematics. So what we're going to be doing is 1 to the 4 plus 2 cube over 12 times 1 cube minus negative 2 to the 4th plus 2 all this to the 3rd power over 12 times negative 2 cubes. That's 1 to the 4th is 1 plus 2 raised to the 3rd power. 1 cube is 1 times 12 is just 12 minus negative 2 to the 4th power is going to be 16. Agreed?
Yes.
Plus 2 raised to the 3rd power. Negative 2
So
cubes.
hold on. Shouldn't that be negative 16? Because
No,
negative.
positive 16. When you raise a negative number to an even power, is negative is positive.
Why?
If you put,
Oh, I know
if you,
why am I get? Yeah, I see why am I get the negative.
yeah,
The
you have to put it in
negative.
parentheses.
Yeah. What one?
No, I'm saying you have to put it in parentheses.
Yes, sir, I realize that.
Mm-hmm. And then now, plus 2 over 3. 2 negative 2 to the 3rd is negative 8. 8 12 96, so this is a negative 96. By the way, 12 times 8 is 96.
Yeah, 96.
All right, so watch me. These two negative numbers will be converted to a positive number when divided. When divided two negative numbers, when multiplied two negative numbers, becomes positive. Watch me now. 2 plus 1 is 3. And we have 3 squares over like 3 cubes over 12 plus 16 plus 2, that's 18. Hey, when I take out the calculator for this year, because at this time of the evening, I can't evaluate that out of my head. 3 3 is 9, 9 3 is 27. This is 27 over 12. What is 18 cubes?
5,832.
How much?
5,832.
What's the LCM? Elena, so you're not with me tonight? How many times can 12 go into 96?
Wait,
And what is 8 times 27?
260.
Hmm?
8 times 27.
Yes, sir.
216.
You said 216?
Yes.
What is 5832 plus 216?
So I'm going to restart the computer because it's I guess so I'm gonna drop off from.
All right, no problem.
6,048.
Can that be simplified?
63 minus
What did you get?
63 when you divide the 6,048 by 96, so that's 63.
63 flat?
Yeah, 63 flat.
That just don't look right then.
One more bite for me.
So that is 63 flat. Something
Yeah.
something is off. That's not what I got for my original stuff. All right, let us double check. It's x plus x to the fourth plus 2 raised to the second power, -1, -2. And I differentiate x to the fourth plus 2, I'm going to get 4x cubed. It's going to be 1 over 4x cubed. Okay. So I'm adding 1 to the power divided by new power. Okay, that's fine. And then this is going to be 4x to the fourth plus 2 over all cubed over 3. And 3 times 4 is 12x to the cube. All right, so that line is fine. 1 to the fourth plus 2 all cube. 12 times 1 cube, that's correct. -2 to the fourth plus 2 all over 12 times -2 cube. All cube, that's correct. 1 to the fourth is 4.
Is there something wrong with the question?
No. Question is the answer is actually 2 students got the correct answer already. It's either 477 over 5 or 95.42, whatever 477 over 5 gives. 1 plus 2 is 3, 3 cubes. 3 3 is 9, 9 3 is 27. That's 27 over 12. -2, 2 2 is 4, 4 2 is 8, 8 2 is 16. 16 plus 2 is 18. 18 cubes. 2 2 is 4, 4 2 is 8. 8 2 is 16. 8 1 is 8 and 1 9, 96. That becomes a positive 96. What about the rest of you? Any suggestions? I'm not seeing the error. There's an error in the solution. I'm not seeing it. I'm kind of very tired, but I'm not seeing the error. I'm looking at the question again.
Sir, unrelated, but I have a question
Mm-hmm.
that confuses me. How do you get at the top? Going in too much. At the top, how do you figure out the 1 over 4x raised to the third power?
Differentiate it. You differentiate the function, and then you reciprocate it.
Could you go over that for me, please?
Go over what? The differential?
No, just how you get to it. Just
You differentiate it and you reciprocate it. But when you differentiate this, what do you get?
but where do you get that from?
Here, usually inside the parentheses. I'm differentiating what is inside the parentheses. Unless I'm not understanding your question. What's your question?
Hold on.
So what was the original answer you got?
Hmm?
What was the original answer you got?
477 over 5. You know, so they're not helping me do no work tonight. And they're not helping me do one bit tonight.
Yeah, I'm just
Come on, pen. Come on, come on. Mhm. Mhm.
Yeah, that's how much for me though. I'm on hiatus pretty soon.
Mm-hmm. What is 2 to the ninth? Whoa, that's supposed to be a big number. What is 2 to the ninth?
Until, 82.
5,000, no, 512.
2 to the 9th.
Mm-hmm.
Right.
512?
All right.
2 to the fifth is 32 times 4. What is 32 times 4?
128.
Anybody has a natural display calculator? Can just do this one shot. LCM is 45. 9 into 45 goes 5 times 5 1 is 5. 4 into 45 goes 9. 4 9 is 36. What is 45 times 4? Yo. Guys, wanna talk to me? Wanna want to go to my bed? Tell me.
Sir.
Yeah, but you know,
Sir,
I
we're
mean,
there.
Sir, I solve the fraction, I'm gonna get 95.4.
yeah, but I'm just saying to you, I don't have a calculator working with, and I want you to all work with me with the calculator. And I'm asking the question, and nobody's helping me. Come on, man. I was asking, what is 45 times 4? Is it 180?
Yes.
All right. 5 times 512, negative 512 equals what?
Negative 2,560.
Negative 2,560?
Yeah.
Okay. 9 times 128 is?
1,152.
What is 45 times 8?
360.
360.
Yeah.
All right. So 5 plus 36 is 41. 41 plus 120. That's 221.
Yeah.
Negative 2560 minus, I counted that in my head. Negative 2560 minus 1152 minus 360 equals what?
Negative 4,072.
Those are going to negate and give me 221 plus 4072. This more looks like it, you know. What is 4072 plus 221? 4293
Yeah.
over 45. How do we simplify that now?
95.4.
Is 4293 divisible by 9?
Yeah, it looks, yeah,
Yes, sir. Yes, sir.
it looks so.
All right.
No,
Let
man,
me.
it is.
It
Yeah,
looks
it is. It is.
well, me not sure, so may I say it looks
When
like it.
everything,
I would give 477.
All right. So look at what trick I used a while ago. What is 4 plus 2?
sir, I was about to
6.
say that trick.
Okay, go ahead and say the trick, JJ.
All right.
Mm-hmm.
To explain, when you have a big number like that, as Sir said, 4 plus 2, that are what? That are 6, right?
Yeah,
And 6 is obviously divisible by 3. So 6
right.
plus 9, I want to know. 6 plus 9,
Our,
about 15. That is still divisible by 3. And 15 plus 3, that are 18, that's still divisible by 3. So whenever you add all the numbers in the big number, and it is a number that's divisible by 3, then yes, it is divisible by 3.
by 3. But sir, ask about 9 and 9 other answer.
Yeah, but it's the same difference because 4 plus 2 is 6.
Look on even
6 plus
45.
9 is 15, and 15 plus 3 is 18. Is 18 divisible by 9?
Or, oh, yeah. Makes
Yeah,
sense.
man. Good.
Yes,
Thanks,
sir, look on even
JJ.
45.
Mm-hmm.
45, same thing.
So
Yeah.
9 divided by
So I
429.
knew 45 was, yeah, definitely divisible by 9, but I was sure about top number. So thank you.
So
Thanks for that.
4293 divided by 9, give me what?
95.4.
I didn't hear that. Say it again, please.
95.4.
No. 4293 divided by 9 gives you what?
477.
477.
477?
Yes.
All right. So this is it as a fraction. That's the answer. Your homework, because your sir is tired, your homework is to go and fix what I have in purple. So what I have in brown is correct. 477. Oh, no, it's not correct. because I left off my unit squared.
Sir.
Oh my gosh, sir, you have to do better.
So it's no correct. For 477 over 5 unit squares is the answer there. Your homework for Friday's class, guys, is to go and fix the one in purple and tell me where we went wrong for that one. Please. And without any further ado, big up on yourself. Have a good night. Yeah, man. Thanks
Sir,
much. Yes, please.
sir,
Go ahead.
just to fix the one in purple. Where's the purple?
And a purple, this one, the one to the left of what we just did.
Sir,
We
that
never.
light blue to me.
Okay. Well,
But anyways,
yeah, that one, the blue purple to the left of what we just did. So this
you
four
know
seven.
all people colorblind, but okay.
I forgive you. I forgive you. All right. Big up on yourself. I will sleep and wake up and look back at that
all
one.
right.
Yeah, something went wrong. And I will need to grab my own calculator and do my own calculation here. But yes, 477 over 5 unit squares is the correct answer. Have a nice one, guys. Big up on yourself.
Big up yourself, sir.
Yeah, man. Easy. Cool.